In this video, we're going to take a look at how we calculate the volume of a three-dimensional shape. So when we talk about volume, volume is the amount of space that something occupies. So how big something is, how much space it takes up. Volume is always measured in units cubed. So if we look at our units here, we see that little 3, that exponent. So anytime we measure volume, we want to make sure that we include that 3 with our unit. And then another important thing to note, anytime we use pi, we're going to substitute in the value 3.14. So we have two shapes that we're going to be looking at. We have the rectangular prism, which looks like a shoebox, and then a cylindrical prism, which is like a cup, a can, or a water bottle. And when we calculate volume, on your formula sheet, we're going to use the formulas that start with V. So V equals. We're not going to be using the surface area formulas right now, so you can go ahead and cross those out in your notes packet. We'll come back to those later. So the first thing we need to do when we're asked to find volume is figure out which formula we're going to need. So if I look at this example on the left, I see this box here, and this is closest to the rectangular prism. So I'm going to copy down the formula, V equals LWH. And now on my shape, I need to label the length, the width, and the height. So I'm going to pick the 7.5 here as my length. I'm going to pick this 4 as my height. And I'm going to pick this 2 as my width. Really, it doesn't matter because I could take that box and spin it around and either of those will come in, but it's okay. Now I'm going to substitute. So I'm still going to have V equals, and instead of my length, I'm going to put 7.5 in parentheses. So this is just like when we evaluated expressions. Then for W, I'm going to take out the W and put 2 in parentheses because that was the width. For H, I'm going to take out the H, put in parentheses, and fill in the height that we had marked off. And now I'm going to let Desmos do the rest of the work for me. So in my Desmos calculator, I'm going to type in everything that I have written after the equal sign. So I have parentheses 7.5, parentheses 2, parentheses 4. And on the right side, it gives me my answer. So that means that my answer is 60. Now I need to make sure I include a unit. So here I see IN for inches, so I'm going to put that here. And then remember we need to include the units cubed. So I'm going to say that this is 60 inches cubed. If we look at the next shape, this looks like our cylindrical prism, or our cylinder. So I'm going to copy down the cylinder formula. Volume equals pi r squared h. And now I need to figure out what those values are. So pi is always going to be 3.14. We can put that in parentheses here so we don't lose track of it. I'm going to take r and square it. R is that radius of that circle at the top, which is 5. So that is going to go in the place of r. And then h, my height, is this measurement on the outside, which is 15. So we have pi, r, which is 5, squared, and 15. Now we come back to Desmos, and we're going to type that in. And if you have anything old in Desmos, you can just hit clear all, and that'll get rid of it. And now again, we're going to type in exactly what we see. So parentheses 3.14, parentheses 5, close it, click the squared button, and then parentheses 15. So I want to make sure it matches what I've written exactly. So this is 1,177.5. And now we need a unit. So I see that I have feet here, and volume is always units cubed. We can also use this to solve word problems. So if I look at this first example, the excavation for a house is going on, and the trucks have to carry the dirt away. And we have this shape that has been dug out in the ground here. So we're looking at this shape here. And we want to know about how many level truckloads are necessary to remove the dirt. So we have the shape that's being dug out, and we have our truck. And both of these look like the prisms. So I'm going to copy down that formula. And I'm going to find two volumes here. I'm going to find the volume of the truck to figure out how much they take away each time. I'm going to find the volume of the hole to figure out how much total needs to be taken away. So if I look at my truck, I'm going to say that my length was 5, my width was 3, and my height was 2. So I'm going to say volume equals length, which is 5, times width times height. And now we're going to let Desmos do the work here. So we're going to come back to our calculator. We're going to have 5 times 3 times 2, and that gets 30. So the truck holds 30 cubic meters of dirt. Now we're going to do the whole. I'm going to say that 14.5 is the length, 4 is the height, and 11 is the width. So now if we look at the whole, we're going to substitute our values in. So our length is going to be 14.5, our width is 11.0, and our height is 4.0. Go ahead and substitute that into Desmos and see what you get for your answer. All right, so we come over into the calculator, we clear it all out. We're going to type in exactly what we wrote, 14.5 in parentheses, 11.0, and 4.0. And this is all multiplication. So we have 638 total meters cubed that we need to get rid of. So now we want to figure out how many times does a truckload go into that total. So I want to know how many 30s are there in 638. So we're going to do division. We are going to do 638 divided by 30. And we're going to come back to Desmos and do that division. So we're going to get rid of everything here. 638 divided by 30. And we get 21.26 repeating. So we're going to say it's about 21.3 truckloads are needed to remove that dirt. For the next one, we want to know how much salsa is missing from the jar. So this looks like my cylinder. So I'm going to say volume equals pi r squared h. And I need to figure out the total volume of the jar. Then we need to figure out the volume of the salsa, because the salsa only comes to about right here. So if I look at my whole jar, I have my radius, which is 5, and I have my height, which is 10. The 4 is just the height of the salsa. So I'm going to start with the volume of the jar. So we have volume. Instead of pi, we always have 3.14. Instead of r, we have 5 squared, and then h, which is 10. So now we come to Desmos, and we're going to go ahead and get this typed in. So we're going to have 3.14, then the 5, and then the squared, and then the 10, and we get 785. We look at our unit, that's centimeters, so centimeters cubed. Now we want to figure out how much salsa is in the jar. So we're still going to have our 3.14. Our radius of the salsa down here is still the same as the radius at the top. So our radius is still 5, but the height of the salsa is just 4 centimeters. So go ahead and plug that in Desmos and see what you get. All right, so if we calculate this out, we have 3.14, make sure you type the right thing in here, times our radius squared, times 4. And we get 314 centimeters cubed still. But we want to know how much is missing, what all of this is here. So I'm going to take my total, and I am going to subtract the salsa that's there to figure out how much salsa was missing. So we're going to take the total, take away the amount that we have, to figure out the amount that's missing. So now that's going to be 785 minus 314, and we get 471 centimeters cubed. For the last one, we have a rectangular wooden sandbox filled with 108 cubic feet of sand. So rectangular means we're dealing with our rectangular prism. We know that it's filled with 100 cubic feet of sand, 108. So that's this, 108 cubic feet. That's the volume, because we're talking about how much it's filled up with. So I'm going to start to fill in the different numbers in my equation here. Instead of V, we have 108. Then we're told that the length of the sandbox is 9 feet. So length is 9. The width is 6 feet. So our W is 6. And then it says, what is the height? Which means that we don't know. So we're going to solve this little equation that we've set up here. We have 108 equals 9 times 6 is 54 times h. Then we undo multiplication with division. And 108 divided by 54 is 2. So our height is going to be 2 feet. Because height always has just that regular unit.